So for area between curves, you could see the first one. This is what we want. Today, this is what we want. We want the green stuff. It's not green on your paper, I know, but we want to find the area of the green. So it's pretty easy on how we do it. The idea is easy. We take the area underneath the top, all of the area underneath the top, right? Everything underneath the top, F's the top. Find all of that area, which we've done before. We've done this all semester, right? Find area under the curve. So we start there. And then we find area under the lower curve, right? G. We find the area under the curve, the pink stuff. We find those two areas and we subtract them. When you subtract them, you're left with area between the curves. Okay? That's the difference. So it's really two things we've done before. We've spent all semester finding area under the curve. So we're finding area under F, right? That's just area under F. You guys know how to do that? And then the second thing we're doing is finding area under G. Okay, finding area under G. We've done that before. Subtract them. You're left with what we want. Okay, so it's essentially just doing two things, or three things. Area 1, area 2, subtract. Okay, which is why sometimes we put them together. So instead of doing two separate problems, since they have the same bounds, we can just do it together in one. F minus G from A to B. Okay, that's what we're doing. So there's two types. There's two types of these types of problems. So the first one is a regular, like we just saw, top curve minus bottom curve. Okay, so we got to find the top function, find the bottom function, find the bounds, subtract them, go from there. Sometimes they'll give you a picture. Sometimes they'll give you something to look at. So it's pretty easy to tell which one's the top function and which one's the bottom function, right? If not, draw a picture. A lot of these are calculator questions too, so we can use the calculator to see which one's the top and which one's the bottom, okay? Find the bounds if they're not given. If the bounds aren't given, we have to find them using the calculator, and I'll show you how to do that. Last thing, find the area, okay? Okay, so let's look at example number 1. Example number 1 is a non-calculator question. It says without using a calculator. They've given us a picture though. They've given us a picture, okay? So R is the region bounded, so it's in green on my paper. You see the region bounded? That's what we got to find the area of, okay? F of x is x squared. G of x is negative x squared plus 2x, okay? We got to find the area in between. Well, the first thing we need to do is figure out what the top curve is and what the bottom curve is. So if we were going to label the top curve, we have two curves. Let me highlight them. We got this guy, and we got this guy. Okay? And then we got to find the area in between. So I don't care about anything else except, I can't go in that far, but I only care about the area in between. I only care about this part. I could care less about everything else. That's the only part I care about, okay? So my first question is, what is the top and what is the bottom? Because that's what I need for my formula. For my formula, I need to figure out what is the top, what is the bottom, and find the integral of that. Okay? So let's start with the top. I know the yellow is the top, right? The yellow is the top, the pink is the bottom of that blue area. But I can't find the area under the curve of a yellow. How do I do that? So which one is the top? In other words, which one is the top that I can put? I can't put the word yellow in here. That won't do me any good, right? So which one, in terms of my formula, is the top? Okay, so f of x. So f of x is x squared. What does x squared look like? Okay, so what does x squared look like? What does this graph look like? If I could use a calculator and graph this, which you shouldn't need to because you've seen this a million times. You've seen this graph probably since junior high school. Junior high is probably the first time you guys saw that graph. Definitely in math 1, definitely in math 2, definitely in math 3. What did this guy look like? Exponential? No, not exponential. Exponential is when I have my variable as an exponent. My variable is, my exponent is 2. So exponential would be something like that. So what does this guy look like? No, not a piecewise. What would this guy look like? The only guy I'm circling. I don't care about G right now. Because you got to know which one's the top and which one's the bottom. Because if I put the wrong one here, if I put the wrong order, I'm going to get the problem wrong. So I have to know which one's top and which one's bottom. To do that, I have to be able to recognize which one's F and which one's G. Right? Is the pink F? Is the yellow G? Is it vice versa? I have to be able to tell that. And I can't use a calculator to verify. So these are pretty easy to tell. If I asked a Math 2 student, they would be able to tell me this pretty quickly. So I figure you guys, this is pretty easy. What does this guy look like? Okay, so we just said yellow graph, now we're saying pink. So what does this look like? So now I'm confused. What does this look like? Just tell me what this looks like. What does that picture look like? We need to do next test. I'm going to put some graphs on there and see, because we did at the beginning of the year. This is one of the ones, this is a gimme right here. We should know this one. We should know what this looks like every day of the week. Like a half U? What is that called? What's a half U? What does a half U look like? I know what a U looks like, but what does a half U look like? A U, but you cut it in half. So it's still a U though, right? Semicircle? No. Polynomial? No. What does this guy look like? I'll give you a hint. I'm not going to tell you because it's something you should know. What does this guy look like? There you go. Which is a arrows up or arrows down, right? That's how parabolas look. They're quadratics. Their powers are squared. If their powers are squared, then it's either going to look like that or it's going to look like, oops, the other way. Like that. They either got two options. How do I know they're going to look like that? Because their powers are 2. Their biggest power is 2. So they're quadratics. Okay, so now let's go back to our question. Which one is F going to look like? The left or the right? which one is g of x going to look like? So why do they look different? My question is, why are they different? Why is one going to look like this and the other going to look like that? So if it's positive, arrows up. If it's negative, arrows down. Okay? All right, so now let's go back to our picture. Which one is arrows up and which one is arrows down? So we need the top one. The top one looks like it's arrows down. It's wide because you can tell the graph is by 0.2s. They're not going by ones. They're going by 0.2. So they really kind of zoomed in. That's why it looks wider than normal. So this guy is arrows down. That's that guy. So the top is g of x. Okay? The bottom is arrows up. Again, they look wider than they should because look at the graph. The graph is going by 0.2, 0.2, 0.2. Usually normal graphs go by ones, right? So if I were to, they just zoomed in on this graph. That's why it looks wider than it actually is. Okay? So that's going to go, arrows up is going to go here. Okay? I know what top, I know what bottom is. Okay? Next question. Bounds. Where do the bounds go? The bounds for these guys go from left to right. So where are the, in other words, I'm asking you, where are the bounds of region R? Where is region R closed off from left to right? Okay, so I need points. So right there is one of them, right? And right there is another one. Oops, I shouldn't use those colors. Let me use a different color. Let's see. I'll use white. There and there. Those are the two bounds that close off R. That's what I want. So I'm going to go back over here. So what number is going to go on the bottom? From what number to what number are the bounds? Look at the picture. From what number to what number are the bounds? We just made dots for them. So this guy is 0, 0. This dot up here is 1, 1, right? So what goes for the bounds? The x values or the y values? The x values, right? So from 0 to 1. There's the equation. Now, if we can use a calculator, we would just throw that in our calculator, but we can't for this guy. Okay. So we're just going to simplify. So I need to distribute. So we get negative 2x squared plus 2x dx. Okay, antiderivative. Negative 2x to the third divided by 3 plus 2x squared divided by 2, and I have to evaluate it from 1 to 0. So I get negative 2/3 x cubed plus 1x squared, and I have to evaluate it from 1 to 0. Okay, so I'm going to plug in 1 first. We've done this part many times before. Haven't done it in a while, but still, you guys have done it lots. And then I'm going to plug in 0. Okay. So 1 cubed is 1 times negative 2/3 is negative 2/3 plus 1. So I got negative 2/3 plus 1 minus. Over here, I get 0 cubed is 0 times 2/3 is 0 plus 0 squared is 0. So in other words, it's negative 2/3 plus 1 whole, which is positive 1/3. So the area between the curves, so the area of R's area equals 1/3 whatever units. Okay? Draw a picture so you can tell which is the top, which is the bottom. They did that for us. Which is the top, which is the bottom, find the bounds, and then do the rest. That's all, every problem we have today, that's all it is. Okay? The second one, example number 2 on the next page, they gave us a picture as well. Okay? So this one, they said we can use a calculator. So we can use a calculator on this one. Some of them you can use calculator, some of them you can't. Just depends on what the directions say. So this one we can use a calculator. Okay? So I got to find the area of R. Like I said, it's green on my paper, but not necessarily on yours. Okay, we got 2 functions. We got f of x and we got g of x. We got to fill those out. Once I have that filled out, then I can just put it in my calculator, but I need it filled out. Okay. So, which function is on top of the green? Which function is on bottom of the green? So f of x is quadratic again, right? So we know, and it's got a negative, so we know it's going to look like that, right? So f of x is on top. So f of x is this guy here. The other guy is linear. It's just a straight line. So f of x is on top of the green. Okay, so we're going to put that on top, or the first. Negative 3x squared plus 5. So that means g of x has to be on bottom, which it is. Okay, done. Now we got to find the bounds. From left to right, where are the 2 bounds that close off R? There's always going to be 2 points that close off R. This one's from left to right. So just looking at them, I can tell that that's going to be this guy here. Use a different color. I'm use orange. This orange dot and this orange dot. So the first orange dot looks like it's left negative 0.8, 0.75, I don't know, up maybe 3. Don't really know, right? The bottom looks like it's right a little over 2 and down a little less than negative 8. So it's kind of in that gray area. I don't know. Luckily, we've done this recently. I have to figure out where those 2 points are. So how do I do that? We've done this within the last few days. How do I do that? There you go. We've done that, right? Put them in your calculator. So let's go get the calculator and let's go put those two guys in. Let's go create that picture on our graph. It said we can use a calculator, so let's use a calculator. Okay, grapher. I want to put an equation in. The first equation is f of x, which is negative 3x squared plus 5. Negative 3x squared plus 5. Enter. Next equation. Oops, no. Next equation is negative 4x. Negative 4x. Enter. Top is going to be red, bottom is going to be blue. Go to the grapher, and there it is. Okay. I already knew what the picture looked like. I just want to know where they cross. So I'm going to go to calculate. I want to calculate where they cross. Go over to calculate, calculate. Doesn't matter which one you pick. You could pick the top one or the bottom one. Doesn't matter which one you pick. You're going to pick one of them. And then you're going to go scroll down to where it says find. I want to find something. What do I want to find? I want to find the intersection. So it's going to tell me the two intersections. So there's the first one. It tells me the one on the left. Negative 0.7862996, comma 3.1455199. Which number do I want? Both? One of them? Which number? Which of those do I want? The x value, right? Because that's my bound. So I'm just going to round that number. Negative 0.7863. That's my first bound. Go to my second bound. So it's already in intersection mode. So all you got to do is scroll over, hit right arrow, and it goes to the other one. The other one is 2.119633, comma, negative 8.478532. Again, I just want the x, right? So 2.1196, 2.1196. I'm going to go put that on the top of the bound. That's the area of R. Done. Now just put it in your calculator. We have everything filled out. So now we're just going to go put it in our calculator like we've been doing. Don't need the graph anymore. So I'm going to go home. And then I'm going to go to calculation now. Go to the toolbox. Calculus. Integral. So what is it? Negative 0.7863. Negative 0.7863. The top is 2.1196. 2.1196. And then I had top minus bottom. Top was negative 3x squared. Plus 5. Minus, parentheses, negative 4x, close parentheses, enter. We get the area is 12.269. 12.269. $12.269. Done. So the nearest thousandth. So thousandths at 3 places. So that's what we did, 269. Okay. All right. Most of these are going to be calculator problems. Most of these will be calculator. There will be a few that they can't use a calculator, like number 1, but most of the ones you have will be calculator problems. So be able to use the calculator, that's going to be big, especially, like I said, this chapter, especially because we've been using it already. Okay. All right, so here we go. Find the area of the region bounded by f of x, which is e to the x. That's exponential. G of x, which is just x, 1x. And the vertical lines, x equals 0 and x equals 1. This one you can use your calculator. It doesn't say calculator, but you can use your calculator on this one. Okay? So what do I need to do first? What's the first thing I need to do to solve this? I know there's area that I need to find because it says find the area bounded. But what's the first thing I need to... Let's draw a picture, right? I don't know where it is, right? Use your calculator. Don't use your calculator. Draw a picture. It doesn't matter to me. Just, I need a picture to look at. I have no idea what's the top, what's the bottom. I have no idea where the bounds are. No clue. So you can use your calculator to draw a picture. That's fine with me, but I need to see something. So I'm going to draw a picture. Okay. So you can go to your calculator and draw these two. They're not very difficult, but if you want to use your calculator, you can. So the first one, so we're going to change, we're going to go back, enter. E to the x. E to the x is right underneath shift. The other one is just plain old x. To zoom in and zoom out, you just hit the plus and minus. So if you want to zoom in, hit the plus. If you want to zoom out, you hit the minus. Okay. Navigate will, if you want to see different parts of the graph, you can hit navigate. That shows you different parts of the graph. Okay. So that's what it looks like. It doesn't look like it's being bounded by anything, though. There's no like bounding, right? They don't even touch. The blue and the red don't even touch. So how do we look at this? Well, that's where the other part comes in. It says there's two vertical lines. Here's the thing: on your calculator, you can't draw. I don't know of a way to graph vertical lines. You have to do that by hand. Okay, so this guy I think would be better. It's a good idea to see where it's at, but it's for this guy, I think paper is better than anything. Okay, so e to the x. So draw e to the x on your paper. So actually e to the x. If you don't know where e to the x goes, just go to your table. Table, or go up to table. So for e to the x, the first dot is 0, 1. The next dot is at 1e, which is about 2.7. And then 2, 7.4 around, 7.4, which is, so this guy's going to be going like this. So you know what? Let me draw this in red. The other one, well, that table's there too. You just got to scroll down. First dot is at 0, 0, 1, 1, 2, 2. Okay. That's what we see on our graph. That's the picture we saw on our graph when we went back. Let me go back to the graph. Graph, graph, graph. There you go. Okay. Now we got to put in the vertical lines. So the vertical lines are x equals 0. It's they're nice enough to tell you it's a vertical line. So x equals 0 here. That's just the y-axis. X equals 0 at 1 as well. So when you do that, now you can see the area that's bounded. That right there is R. So like I said, a lot of times when they let you use the calculator, it's great. They let you use the calculator, but the calculator really didn't help with finding R. So you got to be able to know what the others look like. You can use the calculator. Calculator is a tool, but it won't give you the answer straight up. Okay, so I need to find the area, the blue area. Top minus bottom. So which one's the top, which one's the bottom? F of x is the top, which is e to the x. So I'm going to put that here. And g of x, which is the other one, is the bottom. Good. What are the bounds? 0 to 1, right? Those are the vertical lines. The vertical lines are 0 to 1. Done. Now you can use the calculator. Now the calculator will be a big help. Once you do that stuff, you're good. So now I can go back to calculation, toolbox, calculus, integral, 0 to positive 1, parentheses, e to the x, close parentheses. Oops, no, I don't want that. Minus parentheses, x, close parentheses, enter. 2.128. 2.128. Done. Okay. All right. All right, let's look at the next page. 2 more and then we'll be done today. We'll leave the last 2 pages for the ones in terms of why we'll leave that for Monday. So we'll just do 2 more, we're done. Calculator. Okay, that's nice. Okay, find the area bounded by f of x and g of x. So bounded by f of x and g of x. Again, I need a picture. So we can go to our calculator to get a picture. Okay, so let's see, graph. I'm going to go up to expressions or go back. Oops, no, graph. If you want to change the graph, just go up to expressions. That's where you plug in the graph. Oops, no. There we go. And then hit enter. So the first one is different. The first one is x divided by, so we get division, x. Bottom is a root. It's a square root. So square root of x squared plus 1. So square root x squared plus 1. Okay. And then the other one's x to the 4th minus x. Enter. Okay. Go up to the graph. There it is. So again, plus and minus. Once you get to the graph, just hit the plus and minus, the addition and subtraction. That will zoom in or zoom out. Plus zooms in, plus zooms out. If you want to navigate, if you want to move around, go to navigate. And then you can look at different parts of it and then say, I want to, because we want to look at this part. That's the part I want to look at. I want to see which one's the top and which one's the bottom. That's the main thing for me I want to see. So I can see that the red is the top, right? The red is the top. Take a picture of this. The red is the top, the blue is the bottom. Okay, so which one represents red? Which one represents red? Or maybe it was a different color on your graph, on your I'll do that later. So which one was the top? F of x or g of x? Yeah, it's easy. So there's an easy way to check, right? Go back and say, okay, so on mine, it was the red that was on top. Which one was the red again? Oh, the red was which was F, right? So F is on top, G is on bottom. Good. So I'm gonna go write that down. F is on top, G is on bottom. Good. So sometimes, like for this guy, I wouldn't draw a picture on my graph. If you can tell enough from the calculator, you don't need to actually draw a picture. The other one, the one we just did, one with ease, I needed to draw a picture because I didn't know where it was bounded, right? I could see the red and the blue, but I didn't know where it was bounded unless I drew, because I couldn't draw that on my calculator. This one you can draw on your calculator, okay? So the next thing I got to do is where do they intersect? They intersect here and they intersect there, right? It looks like 0, 0 they intersect, and then it looks like 0.1 or 1 point something maybe. I don't know. So I got to figure out the intersections, right? So intersections, go to calculate. Doesn't matter which one you pick. I need to find the intersections. So the first intersection was at 0, 0. Second intersection was at 1.1808. 1.1808. 1.1808. Done. Throw it in your calculator and you're done.
Thank you.
When you do that, you should get a number around 0.7854. Okay. Okay. Okay, so next one. Last one we're going to do today. Last one we're going to do today. So this one, find the area in the first quadrant. So they only want the first quadrant. That's where everything is positive. X's and Y's are positive. By y equals square root of x, y equals 0, and y equals x minus 2. Okay, so let's graph those and see what they look like. Y equals square root x. Y equals 0. Y equals x minus 2. Okay, we got our three graphs. It tells me that y equals 0 is a horizontal line. Y equals 0 is the same thing as the x-axis. Okay, so I'm going to go take a look at it now. All right, I can't really see it, so I'm going to navigate a little bit. There we go. Okay. Okay, so this is what you're looking at. All right, this is what we're looking at. So we want the first quadrant. The first quadrant is this area right here. That's R. It's where X is positive and Y is positive. So we got to find area of R there. All right. So next step, which one is the top? Which one is the bottom? So just tell me colors. You can just tell me colors on mine. Which one's the top? Which we'll clean up. Which one's f of x, g, because we got three different things going. So if I wanted to find area of this guy, what would the top color be? Red. I agree. Red's the top color. What would the bottom color be? Yeah, that's why, right? Sometimes it's blue, sometimes it's green, right? This is one we're going to have to split into two smaller pieces. So watch what I do. Watch what I do. We're going to call this R1 and we're going to call this R2. Why did I do that? Because the reason you guys just paused. When I said, what's the top? You guys are red. And then when I said, what's the bottom? You're like, right? It could be both. It could be both. So for R1, that area of R1, the red is the top, blue is the bottom, right? R2, red is the top, green is the bottom. I'm going to find the area of both, add them together. Okay. So I got R1 area, R2 area, and then R1 plus R2 equals what? Okay. So we said for R1's the left side, right? R1's the left side. We said the red is the top. The red is the square root of x. The bottom was the blue, right? The blue was y equals 0. Okay. What are the bounds for R1? From where to where? 0 to 2, it looks like, right? 0, and it looks like 2 here. It looks wherever the green touches the blue. We can check that. We can check where the green touches the blue, but it's going to be 2. It's 0 to 2. First one done. Now the second one. We said the red was still the top. R2 red is still the top. Green is now the bottom. Green was x minus 2. Green was x minus 2. Where are those bounds for R2? 2 to 4. It looks like 2 to 4. Again, we could check these. You could go in your calculator and say, hey, where do green and blue intersect? It would say 2, 0. Where do red and green intersect? The calculator would say 4, 0. You can check those. On a test, I would check those. But for right now, we don't have to. Okay? So now you're going to find the area of both. So go use your calculator. Okay, so for R1, I got 1.886. For R2, I got 1.448. Don't take my word for it. Actually check. It's good practice to check on your calculator. It's to check on your own. When I added them together, I got about 3.33. Okay. So every problem we've done today. So we've done what, 4 problems? 5 problems? We've done 5 problems. Every problem we did top minus bottom, and then the bounds were left, right. Monday, what we're going to do is we're going to reverse that. We're going to look at things that we need to look at in terms of why. So you see something say x equals, x equals. Okay, so when we do that on Monday, we're not going to be looking for top minus bottom. We're going to be looking for the right curve minus the left curve. And then the bounds are going to be from top to bottom. That's the difference, okay? So we'll do that on Monday. That part we'll do on Monday. But for right now, that's good. Good practice, okay?